Okay, so welcome back to lecture once again, guys. Now, in this lecture, I'll be talking about a Z score, basically. So let's try to understand that what is this Z score and a standard normal distribution. So here, the topic is Z score and a standard normal distribution. Let's talk about this one. So basically, Z score formula says that Z is equals to data minus average divided by standard deviation. Yeah, standard deviation. Now, so here, right? So here, whenever there is a data which is given to me, for example, data is basically 1, 2, 10, 8, 4, 9. So this is the data set which is given to me. Now, if I have to convert this data in a standard normal distribution form. So maybe this data is available in a normal distribution form. So where I have some mu and I have some standard deviation. Yeah, I have some mu or maybe I have some standard deviation. Okay, that's cool. But there is another term called as standard normal distribution. So, and there is a small differences you will be able to find out. So normal distribution says that it is supposed to, your data is supposed to form a bell curve, uniform, this kind of a distribution it is supposed to form. And obviously this midpoint is going to be represented by mu, and then obviously there will be one standard deviation, two standard deviation, three standard deviation. Within that, all the data is going to exist. Okay, all data is going to exist. That's cool. This is what we have seen with respect to a normal distribution. Now, standard normal distribution says that obviously data is supposed to form a bell curve, but here, so mu should be equal to 0, means average supposed to be 0 and standard deviation is equals to 1. So in this case, it could be anything based on the calculation. So 1 plus 2 plus 10 plus 8 plus 4 plus 9 divided by 6 is going to be mu. And similarly, I will be able to find out the standard deviation. I know the formula, so I will be able to calculate it. But in case of standard normal distribution, mu is always supposed to be 0, means average is always supposed to be 0 and standard deviation is supposed to be 1 all the time. Yeah, all the time. Okay. So now if I have to convert any given data, let's suppose someone has given me this data, and obviously I'm assuming that mu is not equal to 0 for this data. It simply means that this data could form a normal distribution curve, and we know the formula, a probability density function for this one, which is going to give me the height if I have a x over here that I have discussed in my previous lecture. So there is a possibility, right, that this is going to form a normal distribution curve, a normal distribution it is going to showcase. But if mu is not equal to 0, it is not in a standard normal distribution format. How I will be able to convert, right? How I will be able to convert? So basically with the help of this formula, with the help of this Z score, I will be able to convert. So if I'm going to apply Z, means data minus average divided by a standard deviation. So I'm just trying to shift the scale. Yeah, I'm just trying to shift the scale. So in this way, if I'm going to convert this data by using this formula, I will be able to convert all of this data into a standard normal distribution. And this is what we do at the time of EDA. So at the time of even an EDA operation, so that my data set is going to range in between a smaller range, and it should not give me some sort of like a outperforming or overfitting model, overfitted model or underfitted model. So to reduce that, we are going to convert some data into a standard normal distribution. And this is the meaning of the standard normal distribution. And this is one of the use case of a Z you will be able to find out. The other use case, yeah, let's talk about other use case. So let's suppose there is a question which is given to me. With the help of question, I would like to explain you this one. So there is a question that let's suppose my student X is having IQ score is equals to 140. Yeah. So X, so this is the name of my student X. So my student X is having IQ is equal to 140 and average IQ in my class is 100 and standard deviation is equals to basically 15, right? Standard deviation is equals to basically 15. So what is, or like if I'm going to ask a question that this student is better than, what is a percentage of the student inside the class? That is a question, right? That what is the, or with what percentage this student is one of the best inside the class. Now to do that, what I can do, I can try to calculate a Z. So data 140 is given to me minus mu divided by standard deviation. Now Z is approximately equal to 2.67. Yeah, Z is approximately equal to 2.67. Now this Z is technically representing what? So this Z is technically trying to represent, this Z is technically trying to represent that how many standard deviation a value is, means how many standard deviation this particular value is from a mean. This is what it is trying to represent. We have seen 3 standard deviation, right? We have seen 3 standard deviation, and within 3 standard deviation, so basically all the data, 99.9% of the data is going to exist on both the sides, right? On a negative side as well as on a positive side. So here the Z which I'm trying to find out, and the Z value 2.67 which I'm talking about over here. So this is trying to tell me that how many standard deviation my data set is from a mean. Okay, how many standard deviation this data set is. So it is telling me that it's a 2.67 standard deviation. So here on a bell curve, this is my mu. This is our first standard deviation. This is the second one, and this is the third one. So first standard deviation on a positive side, then second deviation, and then third deviation. So that is telling me that this 140 IQ score is somewhere here, right? This is basically representing 140 IQ score. So this data is, this 140 is 2.67. Let me choose some different pen. So this data set is 2.67 standard deviation away from the mean, right? So this is 2.67. Now, what is the other meaning of this one in terms of a probability? Yes, in terms of probability, what is the other meaning of this one? In terms of probability, if I'm able to, because this area is going to be equal to 1 all the time, whether I'm talking about normal distribution or standard normal distribution, area is always equal to 1 because it is representing the probability, right? So here, right? So here it's telling me that it's a 2.67 standard deviation away from the mean. It simply means that if I'm able to, somehow if I'm able to calculate this area, this entire area, somehow if I'm able to calculate the entire area on my left hand side, yes, entire area on my left hand side, so that is going to be the probability, or that is going to be the actual representation that this student is better than this many or this much of the student, right? Or I will be able to say even the percentile score, that okay fine, so this student is 80% better than all the other student if I'm able to find out. So this is again like I'm using a Z over here. Now 2.67, right? 2.67 is a Z which I'm able to find out. Yes, 2.67 is the Z which I'm able to find out. Now what is this 2.67 is representing in terms of an area? How I will be able to find out that? So there are many online calculator which is available. You can try to use that one, or else, right? Or else, so you can try to find out a Z table, right? Just like a log table. So you will be able to find out a Z table on the internet, and here, so table value represent area to the left of the Z score. So let's suppose if I'm getting 2.67, so on a left hand side, so it is trying to represent all the area. So here 2.67 is a Z score. So how I will be able to find out on table? So just look into this table. Here is a Z score. So on this X axis and as well as on a Y axis, it's been given to you. So I have 2.67, right? So I have basically 2.67. So here you can try to break down this 2.67. You can try to break it down as a 2.6 and 0.7. Fine. Try to look for 2.6 on this axis. Fine. 2.6 I'm able to find out, and then try to look for basically 0.7 here. So basically we have a 0.7. Let me minimize this table. So we have 2.6. We have 2.6 over here. Just see the mark. And we have 0.7 over here. Now, if you are going to draw a line, so this value at the intersection, which is 99,621 point, is representing the area. So I can say that a student X who is having IQ score is equals to 140, he is or she is better than 99.62% of a class. So he or she is 99.6 percentile better, or I can say that the student has scored basically So basically like 99.63% of the population. This is what I can score better than the, so simple. So I can try to make a statement over here that student has scored better than 99.62 or 63, let's suppose. So student has scored better than 99.63% of the student inside a class. So he is falling under that percentile, and we have seen this kind of a score even in case of like a CAT exam or UPSC exam, or in terms of NEET exam and IIT exam, right? We get this kind of a score basically in terms of percentile score. So basically that simply means that I'm 99.62% then the other one. So everyone has participated. We try to find out the average, we try to find out the standard deviation, and then based on this one, based on this area calculation, so we can say that okay, so I am better than 99% of the 99.16% of the students. So that is something again I will be able to find out with the help of Z score. So basically it's a 99.62%. So my student X is 99 point. My student X has scored better than 99.62 percentile of the student inside the class. The average score was 100. Right? Average score was 100 and the standard deviation was 15. So even over here, so Z score is helping me out, and with the help of area, which is nothing but a probability, right? That area is equal to 1, so probability, and that table is representing the same thing. So with the help of that, I am able to find out. So hope this makes sense, and we are going to use it again and again and again so many times. But with that, thank you so much everyone. Take care and see you again.